Good morning, good afternoon, good evening, wherever you're joining in from. Welcome to another live session at the Reactors. My name is Ravneet and I'm the Program Manager at Reactor London. Before we get into the session, please take a moment to read our Code of Conduct. We're all here to learn, so please be respectful of other people's views, understanding of differences, and please be kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Today, we are back with another episode for DAX application data analyst tracked. This is a continuation from yesterday's episode of 30 Days to Learn. So with that, I'm now going to add on Oyelowo and Ahmed, who will host the session. Hello.
Hi, Ram.
Hello,
Good,
Rav.
everyone.
Hi, Ola.
Hi, Ahmed. Nice having this show again. And let me say once again, good morning, good afternoon, good evening, whatsoever the time zone you are joining us from. It is the continuation of the 30 days of learning engagement. And we are currently dealing with learning in Power BI as well as DAX, which is data analysis expression. Yesterday, we had the opportunity and privilege of hosting Ahmed Oyelowo, who is a Microsoft MVP, is a Microsoft Certified Trainer MCT, and is also a Certified Financial Modeler AFM. And yesterday, it was mind-blowing. If you've not checked that session, I'm going to drop the link to our previous sessions, which are well documented, and you'll be able to follow through. And today, we have him here to continue that journey. I promise you, it's not going to be anything less of an excitement and inspiration. I just want to encourage you right now to make your way to encourage others in this, like this video, so that I can have more reach, and also share the link to your friends and so that they can join it, because it's going to be mind blowing. So permit me to make welcome as it take us forward, on this topic. DAX in action. Hi, Ahmed.
Hello.
Okay, still.
Hi, everyone.
Hi, Ahmed. I can hear you now.
All right, awesome. So, good morning, good afternoon, good evening, everyone. Depending on where you are joining us from. And it's a pleasure to be here again today to continue the journey that we started yesterday. Basically, we have started with data modeling, and today we are going to continue from there because we will start with DAX today. Okay. So I will share my screen in a bit, but I just want you to I want to let you know that you probably would have heard a lot about DAX, and maybe you have some fears, and maybe it kind of like scares you, and you are not alone. Basically, is what I'm trying to say. So you are not alone in that journey, and the reason is because for someone to be very, very good with DAX, you are going to need to have a very solid foundations in DAX. That means your theoretical knowledge in DAX has to be very, very solid, and I'm going to hope that with today's session I can help you set that foundation right, and I can basically improve your DAX knowledge from whatever you knew before now. And if this is going to be your first time, I hope it's going to be a very nice experience and a very nice first start for you. So let me go ahead to share my screen. So I'll be sharing my entire screen because I will like to navigate between different screens as well. All right, so today our objective, first, my personal objective is to try to keep it to like 50 minutes. I'll be watching my clock very closely. I want to keep it to 50 minutes so we can have about 10 minutes to ask and answer questions. So we want to learn about DAX, and some of the things you will learn today are going to be on measures, calculated columns, context, and we'll also do some time intelligence, everything between 50 minutes. So some of the things that you're going to hear me say today, you hear me mention functions, you hear me mention measures, you hear me mention filters, context, you hear me mention tables, scalar, all of these words, they are all part of the vocabulary that you need to know about DAX. All right. So we'll start by introducing DAX itself, and the official meaning or the official full meaning of DAX is basically data analysis expressions. Now, you'll be able to use data analysis expressions when you are comfortable with DAX, okay? When you are not comfortable with DAX, then it's going to become difficult analysis expressions for you, and that's when you start to find it very, very difficult to use. So it's good that we are here now, and we're going to take the journey very slowly, and we'll try as much as possible to break everything down for our understanding. So DAX is basically a programming language technically developed by Microsoft, and it's just a combination of functions, right? So I'm going to explain to you what functions mean shortly, and you use it to build formulas inside of Power BI, right? So while Power BI desktop that we must have been using for a while now, can achieve a lot of things just through clicking and dragging, right? Clicking, dragging, dropping things here and there. Can do a lot with that inside of Power BI and achieve some amazing results, achieve, some great insights with your data. There are times when you actually need to construct formulas and you need to construct expressions to bring out, the computations that you need from your data to achieve the visual that you would like to display. And that's where DAX basically comes in, right? Now, some of the most popular things that you use DAX to do is to create new tables or to add columns to your data or to write measures. And I'm going to expand on those things shortly. Okay, so I'll talk about measures in DAX. If you were in the class yesterday, if you weren't there, try to catch up with that recording. So if we're in the class yesterday, I mentioned that data analysis is basically you summarizing your data, okay? Because you need to kind of like communicate the meaning from that data. It's more or less like when you go to maybe to an event and you are supposed to write a report about that event. There's a part where you need to summarize very quickly what has happened, right? So your data is like your full event, while your analysis and your visualization is now your summary, right? And that's when someone can take something away from your data. So when we talk about measures, measures are basically, the way you use DAX to summarize your data sets, okay? We'll expand more on measures later in this class. All right. Now, the next thing you use DAX to do is to create calculated columns. Calculated columns are just, when you connect your data with Power BI, get data from whatever source, maybe from Excel, for example, and then you have a need to use some extra columns in the data, right? So maybe, for example, let's say you have unit price and you have quantity sold, right? And you don't have the amount that the customer has paid. You just have unit price and you have quantity sold. That's what you have from your original data source, okay? But you know that you want to analyze sales amount. Of course, sales amount has to be unit price multiplied by quantity sold. Now, because that is not part of your original data set from source, and you need to use something like that in your Power BI, then you're going to need to create an extra column after bringing in that data into Power BI. That's what calculated columns are in Power BI, okay? Now, what's the difference between measures and columns? I've mentioned two things now. Measures, which I said are a way for you to summarize your data so that you can visualize, right? While calculated columns I just mentioned now is for you to, create extra columns in your data that you need, which are not originally part of your source, okay? So calculated columns basically are going to give you new values in your data table. If you have a table that has, let's say, 10 rows and 5 columns, 10 rows and 5 columns, right? So when you create a calculated table, you are going to have the same 10 rows, but now you are going to have 11 columns now, right? Because you've added an extra column. Now that new column will have values for each of your rows, right? Since maybe you have 5 rows originally, I'm not really sure. I've switched between my rows and my columns, but let's assume you have 5 rows in your original table and you are creating a new column, right? That new column will have values for each of the 5 rows that you had, right? So that's a calculated column. Calculated column again, okay, I think I mentioned that we have values for each of your rows. While measures, on the other hand, are basically the formulas that you use just for you to display them on your chart, which means when you write a measure, you are not creating new data. You know, when you write a calculated column formula, you are creating new data. For example, I mentioned unit price and quantity sold. If you create a new column, that means you are adding to your data. That's for calculated column. Measures, on the other hand, are created on demand. That means they are just formulas that you write. It doesn't create new data for you. You only use that formula, to be displayed inside your chart. And we're going to see some measures today. All right. Now, measures are calculated based on filters. We'll understand what that means shortly. Okay. Now, let me go to my whiteboard so that since we have only a couple of minutes to talk about DAX, so I'll try to make this the most important things you need to know about DAX. Okay. Now we have discussed a little bit of theory. We talk about the fact that DAX is a programming language. You use functions and operators. And we also said that you can use it for creating calculated columns. You can use it for creating measures. You can also use it to create new tables, right? Now, DAX as a programming language that you will use inside of Power BI, I said, if you don't have a good understanding of it, the full meaning is data analysis expressions, but when you are struggling with it, it becomes difficult analysis expressions for you, okay? Now, for you not to struggle with it, for you not to, encounter difficulties with DAX, I would say there are primarily 2 things that you need to learn about, that you need to be very, very comfortable with in DAX, okay? So number 1 is functions. And number 2 is evaluation context. Okay, so these are the 2 things that you have to really be comfortable with before DAX is not going to be difficult for you. Okay, now DAX does have over 250 different functions, and that's where people that had Excel background are going to have some advantages, because many functions in Excel, out of these 250 plus, many of those Excel functions are also existing in DAX, and they perform exactly the same things. So let's start with functions in DAX. What exactly do you need to know about functions in DAX? Okay, so first of all, a function simply is, let's call it something that helps you to perform an operation. So for example, if I go to my Power BI desktop from the model we were using yesterday, if I go to this model, remember this model from our star schema, you have your sales table, which is your fact table, and you have these 4 dimensions for customers, locations, products, and sales. Now, there are many things you are going to try to do with this, your data set. For example, let's say you want to count the number of products that you have. We already learned how to count in school. What could you do? You could come to your products table here and start counting your products one by one. 1, 2, 3, 4, 5, and so on and so forth, right? Now, instead of you doing that, DAX already has something that we refer to as function that can help you to carry out those things, right? So all of those mathematics that you learned in school, addition, subtraction, counting, and so many other things that has to do with data analysis, that you could have used your biro and your paper or probably a calculator to achieve, they already have functions inside of DAX, right? And that's why we said for you to be very, very comfortable with DAX, you need to know about functions. And I said there are over 250 DAX functions. Of course, you are not supposed to know all of the 250, because in your entire Power BI career, you may never use maybe more than 30 of those functions, right? So there are really some very popular functions that you just get to use every now and then, right? 80-20 rule. So you must know functions very well. So what exactly do you need to know about functions? So if we say functions are extremely important and you must know about them, the things you need to know about functions are, I'll classify those into 2 things as well. So the very first thing you must know about function, I would say, is the syntax. Okay, syntax is basically just the input that the function wants. So for example, when we use counting as an example, so if there is a function called count, anytime you try to use that function, count, it's going to ask you to provide an input, right? So syntax basically will contain input. So when you try to use that count function, it will ask you to provide an input. Most likely that input is going to be, okay, so which columns do you want to count values from? And you have to provide the columns you want to count values from for you to see your results, okay? So that's number one. You need to know your syntax very well. If there are 30 DAX functions you want to learn, you have to learn the syntaxes, even though it's kind of like easy for you to get the syntax, because every time you try to use the function, you get to see some kind of like help, which we refer to as Intellisense. It will help you to provide, hey, when you use equals to count, it will ask you to write the column name that you want to count, right? It's kind of like as easy as that. Sometimes it can be a little bit more complex, but you need to be very comfortable with the syntax of the functions that you want to use, okay? Then number two is, I'll call this type. I'm going to call this type just for now. So what is type? So for every single function you have, which we said is more than 250, each of them have something that I'm referring to right now as type. What I mean by type is, does the function give you multiple data points, or does it give you a single data point? I will explain what I mean by that. Okay, some functions, when you use them, for example, when you use count, count is going to return a single number, which is the count. That means it's returning a single data point. Okay, now there are some other functions that when you use them, they don't return a single data point. They are going to return plenty things. They are going to return one or more things. That's what I mean by data points. So for types, your types may return single data points, or they may return multiple data points. Of course, when it returns single data points, we refer to that as a scalar function, while when it returns multiple, we can refer to that as a table function, because it's going to return many things, and we're going to see how that works. Okay, now if you remember, once again, we said that the aim of analyzing data is to do what? Is to summarize the data. Now, when you are summarizing data, you typically are going to be using something like sum to sum up everything, summarize it. You're using something like count to count everything and give me the summary of how many do we have. You'll be using things like average and so on and so forth, right? You see that when you want to use DAX, you are going to need a lot of scalar functions, because you need to be summarizing your data, right? That's where the scalar functions are going to be of help to you. Now, we also have the second type of functions, which are table functions, okay? And for the table functions, you also need them as well. Why do you need your table functions? You need them because your data is sitting inside tables, right? Now, if your data is sitting on tables and you want to summarize, sometimes you are not exactly summarizing the entire table. You're only summarizing a fraction of it. So you are going to need those table functions to help you get the fraction of the, of the data in your table that you really want to summarize. So sometimes you see yourself using a combination of the scalar functions and the table functions, right, in one single formula. Okay. Now let's start by looking at some very, very basic examples, because we won't really be able to cover everything, DAX in the next, how many minutes now? In the next 20 to 30 minutes. So I want to start by switching over to my Power BI desktop and show you very quickly, a calculated column without a function. And then I'm going to show you the one that has a function, okay? Just for you to be able to flow with my example. So let me go over to my sales table. So my sales table right here, you will see that I have a column for sales and I have a column for discounts, okay? Now, if I click on the drop down for my discounts column, you will probably see that these discounts are maybe most likely in percentages. So let's assume that these discounts are in percentages, right? Therefore, if you want to get the value of the discounts, you need to kind of like do what? You need to do discounts multiplied by sales. That is the discounts percent of the sales value. So to do that, you need to create a new column right here. So create this new column. And when you create your new column, you want to specify the name of the column. Obviously, the column should be the header. So let's call the discount amount. Discount amount equal to, now we are not using a function, we are basically using the columns, right? We are using the naked columns right now. It's a matter of sales. If I type in sales there, I will see a list of things that have sales from my model, right? This is what we refer to as Intellisense. Just kind of like helps you out to complete your formulas easily, right? Now, what I want is the sales column on my sales table. As you would have seen, every time you try to write a formula in DAX, there is always this table name, column name kind of, structure to what you need to supply, right? Because you are working against tables in your model, right? So all columns belong to a table. Every single column belongs to a table. So if you want to refer to a column, also have to refer to the table it belongs to as well, right? Now, I really want to pick the sales column. So the sales column, I can just navigate down there and maybe use my tab key on my keyboard to select, or I could just use my mouse to just pick the sales. So sales is what I want, and I want to multiply that by my discounts. I use the same. So discount again, the sales table, and I'm going to hit enter right there, and you will see that I have a new column that has discount, right? That's just a very, very basic calculated column, just to show you that the formula you have written here will return values for every single row that you have of this data set, right? So for the places where you have some discounts, you are going to see that they should contain values, right? So for example, this is more likely like maybe 20% of 36 or something like that. That's what you get for the discount amount, okay? Now, for the sake of flow as well, I'll also introduce you to a couple of functions in DAX. One of the functions I want to introduce you to now is called related. And what the related function does is this. If you remember from the class yesterday, we have a model right here, a star schema model that is normalized, which means we don't have every single thing grouped together on a single table. We have scattered them in different places. For example, if I wanted to see my regions, for example, on this table, on this my sales table now, you see that I can't see region, right? So there's no way for me to see regions. If I scroll through all the columns, region is not part of what we have, okay? But then I have region on a different table called location. Now I'm inside sales, and I want to show the region for each of these sales. But that region, I can't find it except I go to look for it on the locations table, right? Now, the only way I can fetch the values of region from the locations table is if the sales table is related to the locations table. Remember, relationships. So if we check our model, we are going to see that, oh, yes, the sales table right here is well related to this locations table. Now, DAX, like I said, now has a function that can help us to do something like that. What this function does is it will help you go to a related table and fetch the related values, right? So now, each of these sales values, I'm saying, for example, I just want to see the region for each of them as a new column on my sales table, right? In reality, it's not necessary, but just for lesson's sake. So if I create a new column now, what's my objective for this column? I want to fetch the regions. So I'm going to type regions here. So let's call this regions. And how do I bring in regions now? The regions are on a different table called locations table, and I want to bring them here. I'm very much aware of my model, and I know that my sales table is related to my locations table where my regions are. Therefore, I need to have in my brain library the functions in DAX and which one of them can fetch something from a related table. Just like You need to know when you want to count. Of the DAX functions, which one can you use to count? Of the DAX functions, which one can you use to add up total? Of the DAX function, which one can you use to get average? Okay, you just need to know many of these functions like that. So of the DAX functions, which one can I use to bring in values from a different table into a related one? That function is called related. That's just the name of the function, related. Now, when you're using functions in DAX, immediately you type, even if you type only R like this, you see a list of all the functions that start with R. And I mentioned that this is what again? This is Intellisense. So I want a related function to bring in related values from the other table. And you also see that you have an information icon here. When you click on that information icon, it's going to tell you exactly what that function does. And it says returns a related value from another table, right? So let's use related. So once you type in your function completely like this, the next thing you want to do is to open parentheses on your keyboard, and you will see that, like I mentioned earlier, the function is going to ask you for an input, right? It's going to ask you for an input, and that's how you complete your formula, and you close the parentheses. Okay, now the related function, now the input it wants from me is which column do I want to fetch from any of the related tables. Remember, sales is related to sales rep based on our model, is related to customers, is related to locations, is also related to product. So you see a list of all those places where this sales table is currently related to. When you use related function, you see a list of all the tables that sales is currently related to, and all related function wants from you is to specify which of the columns you want to bring from any of those related tables, right? And I want to bring in region from locations table. So I'll just go back to pick region, and I'm going to close my brackets and use this check mark to complete my formula, right? Now, what you're going to see now is that, again, I've been able to fetch the values of the regions inside of this, my current table now. There are many things that may require that you create calculated columns. You will use functions sometimes, some other times you won't use functions. So for example, you could be writing some if logics in your calculated columns to derive a new column that are based on conditions, right? So sometimes you will need to do that. Whereas many other times you will just basically leverage on the relationships that you have, right? So you know that even if I don't bring these regions here, I could still calculate my sales by region, even without having to use this, right? I'm only using this related function now because you will still see it when I start to write some measures, right? So that's just some very basic examples of calculated columns. The other thing we said DAX can also do is to create calculated tables. That means you can even use DAX to generate some new tables yourself, right? Now, if we go back to here, when we talk about functions, and we said two things you must understand about functions are the syntax. You saw that right now with the related function. You just needed one thing. Which column do you want to fetch on your related table, which we supplied? The second thing we said is the type of function. Does it return a single value or does it return multiple values, right? Now, when you are inside a calculated column like this, any formula you write will return a single value inside each of the rows, right? So if you are classifying related as a function now, you know it's a scalar function because it just returns one single value, right? Now let's go and take a look at an example of a table function, right? And we'll also use that to look at an example of how you use DAX to generate a table, okay? So when I was going to create new columns, I clicked on new column right here. If you want to create new table, then you need to go to your table tools and you can click on the new table icon. There are several reasons why you may want to create a table. One very important one is to generate a date table that you need for any time related analysis in your report. You want to have a date table that has a standard elements of calendars like dates, like weeks, like weekends, like holidays, and those things so that you can expand your analysis. When you want to do something like that, then you also need DAX to help you sometimes to create a new table, right? So let's use DAX to create a new table right now. So new table, and the table we want to create, let's say we want to call this table a calendar table, which means we need a table that has dates. Calendar is made of dates. Now, what do I need to know about this? I need to know of a DAX function from the many DAX functions. Which one of them can I use to generate dates, right? Now, one DAX function you can use to generate dates is called calendar auto. That function will help you automatically generate a list of dates that covers all the different date years that you have in your data. What do I mean by that? If your data is from 2014 to 2015, when you use Calendar Auto, you have all dates from January 2014 to December 2015. Okay, so I want to use that function right now. Calendar Auto, you can see the description, returns a table with one column of dates calculated from the model automatically. So I'm going to use Calendar Auto right there. And now, in terms of the syntax of calendar auto, already we know that it's going to create a table for us. Therefore, in terms of the type, it's a table function because it will return a full table, right? Now, in terms of the syntax, it's asking for the fiscal year end month. And you see that this input is in square brackets. When you use a DAX function that has an input in square brackets, what that means is the option, the input is optional. You may supply it and you may ignore it, right? Now we are going to ignore this function. I mean, this arguments, close my parentheses and check mark this. And that basically generates, a table for me, which you can see right here, a calendar table that has a single column that contains dates between 2014 and maybe 2018 or thereabouts, right? So we've seen two examples, one for calculated columns and another one for a calculated table, right? This table we have right now is a calendar table that has a list of dates. I'll show you one more example for a calculated table, right? It's not completely necessary, but I just want to use the opportunity to show you another function. Now we have seen two functions. Related, what does it do? Fetches values from a related table into a new one. Calendar auto, what does it do? It helps you to generate a list of dates calculated automatically within your model. Now, the other function I want to show you now is called filter. And what does the filter function do? Let's say that I go to my products table, for example, right? So this is my products table right now, and it has ID, category, product category, and product name. When you check at the bottom of my table, you probably see that this table has 1,894 rows of data, to show every single thing. Now let's assume that I'm only interested in the office supplies category of products. What would I do? I would come to category right here, use this drop down, and I'm going to use it to pick only office supplies, right? And I'm going to click OK. And you see that I have 1,098 filtered rows that are office supplies products. Okay, so let's take through that process again. This, my products table, I need it to only contain office supplies. That means I want to filter it. I want to reduce the values that are there to only contain what? Office supplies. What do? I come to the products table and then I use the drop down and I use it to pick office supplies and click OK. And then I have a table that has only office supplies, right? Now that manual operation, you can also achieve the same thing by using a function, right? Remember the example of counting? You can count by using a function. All you need to know is which function can I use to define filtering, right? Now let's assume that I want this as a separate table, okay? So what do? I'll come to my table tools right here. Let's clear this filter first. So clear this filter. So I'll go to my table tools and I will create a new table because I want a table that contains only office supplies, okay? So for my table name, I'm going to call this table office supplies products. And what do I want? I want this table to be generated brand new, and I need it to have only the values that are office supplies coming from the products table, right? So the function that can help me to do something like that is called filter. So if I start with filter like this, if you read the description, returns a table that has been filtered. So once I open my parentheses for filter, you see the syntax. First, it wants a table. Which table do I want to filter? I want to filter the products table. So I'll just type in products there and select it, comma. What filter do I want to define? That's the filter expression. What do I want? If you remember, I want the category to be office supplies. So I'm going to say, okay, what I want is I want the category, which is a product category. I want it to be equal to office supplies. Now, when you are writing a formula, you need to type in text value manually in your formula. You put the text value in double quotes. So double quotes, I'm typing office. I hope I get the spelling right. Office supplies. Okay. Then I can close my bracket and I can check mark this as well. Let's see if the spelling is correct. Now, if the spelling is correct, I should have a new table like this. If I go to check the category on this table, what do I expect? Only office supplies are supposed to be there. And that's basically absolutely correct. Okay. Now, the objective of this is for you to understand functions and for you to see that you need to know about different functions in DAX, know what those different functions do. The good thing is most of the analysis you will always do are almost the same thing, the same sets of analysis that we do every time, right? Most times, right? So there's always like a kind of pattern to the things that you will do, and you already know the different DAX functions that can fit in to any of those patterns, right? So in summary, for you to understand functions properly, you need to know about the syntax, know what the syntax does, know how to supply the inputs, and secondly, you need to know about the type of function that you are using. Is it a single scalar function or is it a what? Is it a table function, right? Final example, right? Now, for me to generate this table, I had used filter. What does it mean? We know the syntax. If you're going to use filter, you supply the name of the table you want to filter, and you supply the filtering that you want to apply. That's the filter function, that's the syntax. The second part that I said you need to know is what? The type. What type of function is it? Does it return a single thing? Does it return multiple things? It returns multiple things. That makes it a table function, right? Therefore, if you are going to create a new table in DAX, obviously you must use a table function. That's the only way out. If you don't use a table function, you can't create a new table. Okay. So for example, when we're going to define this, immediately I typed F like this. You already see a bunch of functions that starts with F, right? Obviously, because I'm inside, am I inside new table right now? I'm inside a new table environment right now. The fact that these functions are showing up simply means that these functions are table functions. They return tables for you. That's why you can see them on the Intellisense. Imagine if you try to use sum. See that you don't see the sum function, right? Because sum will give you one single value after summing things up, right? Because it's a scalar function, returns just one single number. So if you try to define a new table with sum will not even appear on your Intellisense. Let's try counts. If you try to use a count, you won't also see it in Intellisense because count is also a scalar function. Therefore, one more time, understand each function, understand their types, okay? And then with that knowledge, you'll be able to scale that up to write some really robust formulas in DAX, okay? Now, let's move on to measures. Measures are like the queen of analyzing data inside of Power BI because at the end of the day, no matter how much Power Query you have done, no matter how much data prep you have done, no matter how difficult, how stressful your data model looks like, your end game is to provide insights through visualization, right? Now, you can easily do all of those visualizations. For example, I'll just go to a new page right now, and I'm going to try to show the sales by our sales representatives, or maybe by the sales teams, for example. So let's say I use a bar chart like this, and because I want sales by the sales teams, then I go over to where I can see my sales, which is my sales table, and say I just tick sales from there. Obviously, if I want to see this sales number by my sales team, I will have to go and locate that on a different table for sales reps. That's why I have my sales team. So if I tick sales team right from there, you see that I do have my results, and I see a visual that has summarized the entire sales table, the entire sales based on the sales team. Okay, but now we are going to try to, create a simple project right now using DAX. And this is what this project is about. We're assuming that, the marketing team is responsible for the sales reps. And let's go check that table first of all. So this is the sales reps table. And like I said, now we're assuming that this table, belongs, or it has details about the marketing team. You see that the sales reps, there are about maybe 15 or 14 different sales representatives. Each one of them belong to one team or the other, and each team has a manager. Okay. Now, if you check through the sales rep, you see that one of them is called organic. The organic sales rep is not a human being. That's the only one that doesn't have surname and first name. It's not a human being. That's just, like a walk-in customer, somebody that was not referred by anyone. This person just basically came in naturally, right? Therefore, if we want to kind of like analyze some data set for the marketing team, it might make sense for us to exclude this organic person from there, from our analysis. And even if you check the visual, you can easily see that, it's just almost like an outlier against every other sales team. Look at the value for organic. It's too much for everyone. So we are going to try to create a simple report page right now. So if I go back to my page 1, and our objective for this report page is we want to display here, we want to display the sales for each of the teams without including the organic guy. That's number 1. And we need to see those values by 2 different sections. First, we want to see the values by a particular month. That means we are going to need to create a slicer that shows us months. So if I pick January, I want to see the sales for each of the teams in January. If I pick February, I want to see the sales for each of the teams in February, and so on and so forth, right? So let's start with that simple one. So let's add a slicer first for that we'll use to pick our month. So let's go add a slicer right here, and I'll just go to my sales table. Let's ignore this calendar for now. Ignore the calendar table. So I'll go to my sales table, and under my order date, there's a date hierarchy there. I'll just put year, and I'll also add month as well. Okay, so that gives me years and months. I will try to make this a drop down to manage space. Okay, so that drop down to manage my space, and quickly drag this right here. So I can use this to pick maybe 2016, maybe 2016 March, for example. So if I pick 2016 March now, what I want to see is when I create that chart right here, I want to see the sales for each of the teams for 2016. Okay, now remember this. Once I use these bar charts this way, and I try to put the sales values, so sales, and I go to my sales team, sales reps table to pick sales team. That shows up for everybody. Of course, there are ways that you can use to exclude this organic from there. For example, I could just right click here on organic and say I want to exclude this, right? But because measures in Power BI are really powerful and they allow us to extend our analysis furthermore, I'm not going to do that. What I will try to do is I will try to write a measure, right? I'll try to write my formula myself, the one I can actually control. Okay. Now, what this is currently doing now is giving me the total sales for each of the teams. I could do that myself by writing a formula using the sum function. So I'll go to my sales now, right click on my sales and create a new measure. And this measure, I'm going to call it, I'll call it revenue. So the name doesn't clash. So revenue, maybe revenue is fine. And equal to, what do I want? I want to sum up the sales column. So I'll type sum of the sales column in my sales table. So sales, sum of that column, close that and check. Now, what do I do next? I am going to remove this one that I have here, and I'm going to replace it with this new one I created. Okay. Now, this new one I just created now, it's a measure. Like I said earlier, measures don't add to part of your data. They are formulas that you can only use in your visuals, right? Now, I've created this measure right now. If you check on my fields panel, if you scroll down, you see it somewhere there, revenue. It doesn't add to data, but I can use it for visual. So if I remove this sales from there, and I replace that with this revenue, it gives us exactly the same thing, okay? Now, the power for measures is the ability to control things. It's like you are programming things yourself, and you can basically extend on the ordinary click and drag that Power BI has. You know, Power BI, click, drag, you achieve a lot of things by clicking and dragging. But with measures, you can do more than that, right? Now, measures on its own has some other conditions that you need to be aware about. So very quickly now, so for you to understand measures, you must have a full understanding of evaluation context. Okay. So evaluation context basically is divided into two parts. There is the one that can help you apply a formula on every row. And then there is the one that helps you apply a formula on a filter. So when you filter something, it helps you to apply that formula. When you create calculated columns, the row context is in place because whatever formula you write will be applied on each row of that table. But you see, when you are using measures, measures are basically powered by the filter context. What do we mean by that? Now, I just created new measure now called revenue. It's just a formula. It's not pointing to any data. It doesn't create any new data set by itself. But the way this formula is now going to work is going to be based on the filters I have in my report. For example, I just use this revenue to show on my sales team. I could use the same revenue to show for my regions, for example. So I could create a new chart now like this, and I'm still going to use that same revenue, and I'm going to use it now against regions. You are still going to see some answers as well. So how exactly is this happening? This is happening based on the filters context that you have on the reports. Okay, now what does the filters context mean? The formula you have written is here. It is summing the sales column of your sales table. Right here, you need to slow down at this point because this is where DAX can start becoming difficult analysis expressions. The fact that you see sum of sales here does not mean that what the formula is doing is to go to the sales table. Remember, right here is your sales table, isn't it? This is your sales table. And if you scroll right here is your sales column. The sales table, the sales column. You check the measure. What do you see? You see equals to the sum of the sales table and the sales column. Now, that's not what's happening. What's really happening right there is this. This sum of sales is going to be based on the current filters that you have. What do I mean by that? If I maximize this chart right now, how many things do I have on the chart? 1, 2, 3, 4, 5. What it simply means is that formula is going to happen 5 different times because measures work based on filters context. The very first thing that will be established before your formula run, before this sum of sales is going to run, this sum of sales that you see here, before it runs, what the formula is going to recognize as sales table, sales column depends on what is being filtered. Okay, now on this chart now, you see 5 things there. That means 5 things are being filtered. So if I want to get the sum of sales now to show up for each of these guys, what's going to happen is the first thing is behind the scenes, DAX is going to have to go to filter the sales table first, filter the sales table internally to show for only organic sales team and then sum it up. It will give you this bar. Goes to the next one, filter the sales table to show for only Delta team, sum it up and give you that, and so on and so forth. That's how this is able to be displayed. And that's why you can use that same formula to visualize another thing, because when you use to visualize another thing, what's going to happen is the filter for that another thing, like region, for example, also be applied first before the sum happens. You must be able to think like that for you to manipulate your Power BI properly. Okay, so now take a look at this. If I clear this filter right now, you see my filter is cleared currently now, right? You see that the values on the chart are going to change. So if I go back again to pick maybe February, you see the values is changing. Now, the reason why the value is changing, the same sum of sales is changing, is because the filters have changed as well. Because now I am now looking at the sum of sales for January 2016, sum of sales for March 2016, for April 2016, and so on and so forth, right? Now, the question is, how do I remove organic from this, right? Let's go back to our functions. Got about just 5 minutes more. So for the functions, we said there are scalar functions. Yeah, we said there are scalar functions and there are table functions. Scalar functions will summarize. You have seen an example of scalar function right now. Sum. Use it to sum up a table, right? We also saw an example of a table function the other time called filter that we use to filter a table, right? Now, the good thing with DAX is this. That means if I want to eliminate that organic from there, what I need to write as my formula has to be sum of the filter table, right? Don't sum, let's go here. Don't sum the sales table as it is. Sum the filtered sales table. Remember how we created filter the other time? If you go back to the other products table we created, office supply products, we use this filter right here to filter the products table to only contain office supplies. So if I wanted to sum up my sales and exclude the organic guys from there, that means I need to use sum again, right? But I can't filter the table. I can't just sum the entire table. I need to sum the filter table. So how do I do that quickly? So right click sales, create a new measure like this. And I will now say, okay, let's call this revenue. I'll just put without organic. And then the formula is going to be, I want to sum, open my parentheses. What's the syntax for sum? Sum wants a column name. Meanwhile, what I want to do is way beyond column name, right? I want to be able to filter a table out first. That's where you have some variants of your aggregate functions. Like you have some, you have the one that can help you to apply an intermediate thing to what you want to solve. Right now, sum only collects a column name, can't allow you to do any type of filtering. Therefore, you are going to switch from using sum to the variant of sum that can allow you to kind of like define what you really want, the kind of table you want. You see that sum will not allow you to define the kind of table you want. It just give you the column name you need and you have supplied that. So the other variant of that one is the sum that has an X, sum X. Now, when you check sum X, you see it has a syntax, the table and the expression. Okay. Now, what table do I want to sum? Probably think I want to sum the sales table, isn't it? Right, comma. and the expression. What do I want to sum on the sales table? I want to sum the sales column on the sales table. Right? If I close my bracket like this and I hit enter like that, right? Close and hit enter. If I change this revenue to revenue without organic, what do you see? You see organic. Why? Because now that I'm using SumX, I've said the table I want is the sales table. I have not removed organic from there. So to remove organic from here, how do you filter a table again? If I want to filter a table, what do I use? Let me just take this into different lines, right? So there were two arguments on SumX, the table and the expression. Okay, this is the table, this is the expression I'm summing up. Now for the table, we say not just the sales table, I need to filter it, right? So I'm going to say, hey, don't sum the sales table. I want you to filter it. So do filter like this, filter. Filter is asking, which table do I want to filter? I say I want to filter the sales table. Good and fine, comma. What do I want to use to, filter the table? I will say I want to remove organic from there. I don't want organic to be there. So organic is what? Is a sales team. I don't want the organic sales team to be part of the table. So I will try to type sales team now. There's a problem. I want to filter the sales table, but I don't want the sales team called organic to be a part of it. Huge problem, because now I can't really do that, because if I go to my sales table, right here, if you check through on my sales table, you can't find sales team there. There's no sales team. But I want to write a formula that is going to remove organic sales team from. One more time, how do you bring in values that doesn't belong to a table into the table? How do you do that? Use related. Therefore, to complete this my formula, I'm going to say, okay, SumX, filter the sales table. I want the sales team called organic not to be a part of it. Therefore, I'm going to use related like this, and then I can select my sales team and say, I don't want the sales team to be organic. So this is not equal to, and then organic this way, close, and yeah, I need to put a comma right here. Okay, so if I check this now, unfortunately, got just 2 minutes more. So when I check this now, you are going to see that what you see that the organic is no longer a part of this formula, and I've now used a measure to create the formula I want. Okay, so just to use the last 2 minutes to quickly introduce calculate function to you, right? One other way that you can also use to kind of like manipulate the filters in your measures is to use a function called calculate. Calculate is a very, very powerful DAX function that can allow you to quickly, modify the filters that is coming from your formula. So for example, now, what's the current filter I have now in this report? If you check from the slicer, the year is 2016 and the month is April. One filter. That means any formula I write now, first of all, filter my data to have year 2016, month April before the formula we apply. So this sum you see here is summing based on after filtering data to year 2016, month April, and then for each one of them, it will now filter. So alpha, year 2016, month April, what's the sum? Charlie, year 2016, month April, what's the sum? That way, that's how measures work. Now, to manipulate my measures that way now, I can start using something called calculate function to build more elaborate things. So for example, if I want to see, let's just quickly drop a card here. I'll just write one more DAX measure, and that will be it. So now if I put that same revenue without organic here, that will give us the total revenue without the organic value, right? That's because I'm not using that measure. 19,000 is total. I'm not using this against any other thing. So the only filter here is April 2018. There is no team, there is no region, there is nothing, right? So finally now, I will now do one more measure now that will help me get the values for March. Remember, my current filter is what? April. But I want to compare this 19,000 to March value. And remember, before your formula is going to be applied, the first thing that is going to happen in your measure is the filters will take place first. So as we are now, any formula I'm writing right now will start from April. May to December will no longer be part of the data. January to March will not be part of the data anymore, right? But now I want to compare this, my April value to my March value. How do I do that? I will now have to use the calculate function to help me manipulate the filter. So if I right click on my sales, I'll create a new last measure of the day. Sorry, time does not permit. So let's call this previous month revenue, and it's going to be equal to, now start with calculate like this. The first argument on calculate or input is expression. What do you want to calculate? I will say I want to calculate that revenue without organic. Okay, comma. Now, this is where you get to now define the filters you want. You are now saying that, hey, I understand right now that revenue without organic has the current month I have selected, which is April. But that's not what I want. I want the one for the previous month. So you now type previous month right here. So previous month just needs a single input, a date. So my date, I can use my orders dates right here. So sales order dates, there are a lot of variants for it. The variant I want is date because that's what previous month function wants. So I'll pick dates, close, check that. That will give me the value for March. So if I put that on a card visual, so just quickly Control C this, Control V this way, and remove this one and use the one for previous month. Where do I have that? So previous month, and it's going to show us that March was 15K, right? So let's verify that March was 15K. Change this April to March, and you see 15K here. This 6 is February. So change this March to February, you see the 6K right there, all right? Okay, so I think I just need to stop right here. Gone 3 minutes past my scheduled time. So I hope that you've been able to learn, even if it's just 50% of the knowledge you are able to gain from this session, you can use that to expand further.
Great. That is really awesome. And I see from the comments in the, dropped in the comment sections. Thank you everyone for, following through and also sharing this. The recording is available as well. All sessions are documented and can be found on the landing page there. Feel free to tweet them. I've made a lot of tweet tagging. I'm Ahmed Oyelowo. So made a lot of discussion topics in the Discord channel. You'll have your questions there. Most importantly, come back to this video and practice and build something from the session that we've had today. I want to say very thank you to our guest for today, Ahmed Oyelowo. It's been, a journey since yesterday. We've been, introducing DAX as well as data modeling and the whole context. And I believe everything is where is clear now. So I want to say thank you and to our producer at the back end, Rav. Thank you, Rav, for helping us to make this session easy for everyone to follow. Thank you all, and let's learning continues. Don't forget to join the Cloud Skill Challenge and participate, and see you on Twitter, Discord, and the other side of the conversation. Thanks and bye.